Welcome everybody to the Northeast Fruit Consortium Winter Webinar Series. Glad you can make some time to be here, and we're pretty excited about today's session. Title of today's session is Why Did My Scab Program Fail in 2024? Dr. Anna Wallis with us today, and she is a Senior Extension Associate with New York State Integrated Pest Management. And as the New York State Integrated Pest Management Program Fruit IPM Coordinator, Anna develops research-based sustainable IPM strategies and increases farmer and producer engagement through extension and research. And we also have Dr. Kerik Cox. He is an associate professor with the School of Integrated Plant Science, Plant Pathology, and Plant-Microbe Biology section at Cornell AgriTech. And Dr. Cox's programs specialize in applied plant pathology, mycology, community and stakeholder education. And the program's mission is to provide a better understanding of the relationships between life history features of fungal plant pathogens of fruit crops and applied disease management practices. So again, want to thank both of our speakers for being here today. And with that, I will go ahead and hand things over to Dr. Anna Wallis.
Thanks, Jeremy. It's good to be here, and I'm excited to see so many people joining us. I wish that we had a better reason to be here. Scab is a pathogen that we know really well, and I think we do a really excellent job managing every year. So we were surprised to have a lot of people report this season that they had trouble with it. We gave this presentation also in New York at the New York Fruit and Vegetable Conference last week. So there's been interest across the region. So I wish we had a better reason to be here, but Kerik and I put our heads together and we kind of looked back at the season and discussed some of the challenges. And then we went pretty thoroughly through NUA forecasting and where the infection events happened and tried to summarize what we think may have happened and challenges that people may have faced this season. So I'm going to start with a brief life cycle review of Scab, not because I think people don't know it, but because I think we need to go back to basics because so many things around the basics are changing. There's a lot of environmental factors, available chemistries that are changing. So just factors that are changing around the basics of Scab that I think it's worthwhile to revisit. Then we'll look back at the 2024 season, a couple of specific sites and go through the NUA system and the infection events. And then we'll get into some management, so some of the exacerbating factors, and Kerik's going to cover some of the best management practices for 2025 and future seasons. And as any good pathologist, I was trained by the best, and so I am going to frame the beginning of this talk with the disease triangle. So if you've seen a plant pathology talk before, you're familiar with this triangle. It just indicates that we need three things present in order to have an infection event and the disease presence. So the first thing is the host. So in this case, for apple scab, we need to have susceptible tissue. We also need to have the pathogen present. So that's having spores that are available to infect the plant tissue. And then we have to have the correct environmental conditions to produce an infection event. So for apple scab, that's sufficient wetting events or leaf wetness and temperatures for those spores to be ejected and infect the plant tissue that is available. So in the next couple of slides, I'll share a little bit about each of those three and then elaborate how they're impacting apple scab and sort of how that's maybe changing in our current conditions and how it can be applied to the 2024 season. So just starting with the life cycle review, this is a beautiful life cycle illustration that actually Kerik drew. And I'm excited to tell you that this image and the entire apple scab fact sheet at Cornell University, we are moving all these fact sheets onto the New York State IPM website. Right now, they're currently available in a PDF format that's a little bit tricky to find. So we're putting all of this information on our website at Cornell University at the New York State IPM website. And so you can access that. We have about 20 fact sheets in progress, both insects and diseases, and we're moving as quickly as we can to get them online. So hopefully you can visit that site and review them there. So just to remind you some basics of the apple scab life cycle, there are two phases that we're really focused on managing this disease. The first is primary infection period. And so that's when the spores are released. Let's see if I can get my pointer out here. So that's when the spores are released from the leaf litter on the orchard floor, and they're ejected into the canopy, these ascospores that are in these sacs in the pseudothecium. And they land on the foliage and can infect the foliage in the canopy. And so if an infection does occur, a lesion develops and secondary spores are produced, and these are called conidia. The conidia go on to infect leaf tissue as well as fruit tissue for secondary infections. And so that's the secondary infection period. So if you manage primary infection period very well, then you don't have to worry about the secondary infection period at all. But if any spores slip through in the primary infection period, you can be chasing secondary infections for the rest of the season, and it can become very difficult. And of course, then those spores land on the orchard floor, they overwinter in the leaf tissue, and it all begins again. Okay, so first looking at those, the host part of this disease triangle, we know as soon as there's green tissue present at green tip, there's susceptibility to infection. So I just pulled data from a couple of sites in New York about green tip and how that's been changing over the past couple of decades for the data that we have available. So you can see all the way from 1980 to present day, there is a pretty noticeable trend for green tip to be earlier. And so in 2024, at the Highland Hudson Valley Research Lab, where I'm based, we had the earliest green tip on record. And that was the case in a lot of places throughout the Northeast. So what does this mean for us in management-wise is our season is just getting earlier and earlier in certain years, which just means we have to be prepared earlier. We have a longer season to be managing. It's making management a lot more difficult. There's also more variability. So you can see the points are scattered maybe a little bit more along this line. And so some years it's very early and some years it's much later. And so that variability just makes it more difficult to predict what's going to happen and management more difficult. Here's the same information for Geneva at Cornell AgriTech. And so you can see a similar trend of earlier green tip dates. Our earliest green tip on record, it was almost at the same time as the Hudson Valley last year. And these are green tip dates for McIntosh that were reported at these research stations. You can see in this graph even more variability around our green tip dates. So just more difficult management. Now moving into the pathogen. So looking at the pathogen that's available to infect that host tissue. So we know in primary infection, we have to have mature ascospores to produce an infection, and those spores being mature depend on both moisture and temperature. So if you're familiar with the revised Mills table, or if you're, sorry, we'll move into that next. First, we're going to look at table 622, which is out of the Cornell Tree Fruit Pest Management Guide. I know that you're using something different depending on the region that you're in. But this shows the cumulative ascospore maturity based on degree days. So you'll notice that at the beginning, it sort of has a slow start. Then a lot of ascospore maturity happens really rapidly during the middle part of this curve, and then it sort of tapers off. So the majority of our ascospores are mature in this center part after we've accumulated over 200 degree days, base 32. And so if you have a very clean orchard, the majority of your infection potential is happening during this time. That isn't to say that there aren't infections happening at the tail end, but that's just where the most of the spores are mature and available. So hypothetical ascospore maturity curves, just to make things super clear. In a cool spring, this might be stretched out over the course of a couple of months or more. In a really warm spring, things might be squished together, and this would happen really rapidly. At the Hudson Valley Research Lab in Highland, this is what happened in 2024. So you can see really gradual start to the season. We had this really early green tip date on March 12th. And then it was cold for a long time. And so no ascospore maturity happened. Around the early middle of April, we see an increase in this curve. A lot of ascospores maturing, and then tapering off to when the model in NUA predicted on May 13th, all of the ascospores had been ejected, so primary affection was over. You can also see around this middle section, this purple lighter shaded portion gets wider, and that just indicates that when we're in the middle of the part of the infection period, or not the infection period, when we're in the middle of that ascospore maturity period, there's a bigger variability in our prediction, our confidence in how many spores are mature. So there's just a little bit more fuzziness in how many spores are available to be infecting the host tissue. So we also know that winter conditions can affect the maturity of ascospores. I've been speaking with Julie Carroll, who is retired from the New York State IPM program and formerly the fruit IPM coordinator for the New York State IPM program. And she has some data that I think she is getting ready to release, hopefully in the next couple of years and publish. But in conversations with her, temperature and precipitation are very critical to ascospores maturing over the winter. Ascospores can start producing initials that would lead to infection as early as February. They don't always or usually, just depending on the temperature and the precipitation. But we know in 2024, we had a really mild winter. We had a lot of days in New York, at least over 50 degrees Fahrenheit. And then in February and March, we had a really warm early period, which led to that really early spring green tip, at least in New York and a lot of surrounding regions. We had a few days that were over 60 degrees Fahrenheit. So that would potentially contribute to early ascospore maturity. With regard to precipitation and moisture, we know that moisture is also needed for ascospores to mature, not just heat. And so if there's a lot of snow cover, some of Julie's data indicates that that could potentially provide more moisture that would lead to potentially an early release. But other forms of moisture, so other rainfall events would also produce moisture. And so those could happen if there's a warm February and March, like I indicated. So I went back and I looked at some of the data from both NUA and from the Northeast Regional Climate Center. So you can go back to this website and you can search by state. And then within the state, they have different regions where they are collecting information on seasonal precipitation and temperatures. And they're showing the departure or the percent from normal. So I went back and I looked at that just from New York. And I'll show you a couple of examples. So just looking at Highland, New York at the Hudson Valley Research Lab, this is showing the high and low temperatures in those lines across the graph, and then the bars are indicating precipitation in inches. And so you can see right away that we had a lot of rainfall in March at this location. And then it was pretty dry right around this time, which is when green tip occurred, interestingly. But to summarize some of this in a tabular format, you can see the first column here is indicating precipitation that was recorded at the NUA weather station at this location. The next column is looking at the Northeast Regional Climate Center for their Hudson Valley station. And then this is the percent of average from the Northeast Regional Climate Center. And so this is January, February, and March. And you can see that in January and March, we had an extraordinary amount of precipitation, almost twice as much as we would usually see. So really wet spring in combination with some really warm temperatures. This chart is showing the same thing, January, February, March, with NUA in the first column, the Northeast Regional Climate Center temperature recorded, and then the departure from average. And you can see that we were about 5 degrees above average for this spring. And so the warm temperatures combined with this ample moisture, we could have had much earlier ascospore maturity initiation than we normally would have seen. So something to keep in mind as we're beginning Scab season, that ascospores can be mature very early. Oops. So this is just the same data. I'm showing a different location, Geneva at Cornell AgriTech. Again, the temperature lines across the graph there, and then bars indicating the amount of precipitation. In this location, we had pretty average rainfall compared to what we would normally see, or precipitation, for January, February, and March. But temperature was also warmer, 6 or more degrees warmer in February and March, which may or may not have led to earlier asks for maturity. Okay, so now moving into primary infection events and the environmental conditions that would lead to an infection event and how they might be impacting what we saw in 2024. So we know a primary infection event is when we have sufficient wetting hours at a given temperature to release those ascospores. And so I've taken the revised Mills table and I've actually broken it down into 2 things. Usually this is all lumped into one table, just to make it really clear that there's 2 things happening here. And so first we're looking at an infection event on the left table. And so this is when the spores on the orchard floor in the leaf litter are germinating, they're being ejected into the canopy, penetrating the cuticle, and getting established in the leaf. And so this is the average temperature, and then the minimum wetting hours that are required. And we wouldn't see anything during this infection event. So there's no lesion, there's no evidence for this to occur, that this is occurring. And so also it's important to notice that most of our infections are happening at warmer temperatures because less minimum wetting hours are required during these temperatures to produce an infection event. On the right-hand side of this table is lesion appearance. And so this is the time from once the pathogen gets established in the leaf, the hyphal development occurs, there's the production of those secondary spores, the conidia. And so at these same temperatures, it can take up to 2 or more weeks for lesions to even appear. So this is really important that you're going out into your orchards 2 weeks after an infection event was predicted and scouting really thoroughly, because that will tell you if you have spores in your orchard that might produce secondary infections that you need to manage for the duration of the season. And so because like in this year at the Hudson Valley Research Lab and in Geneva, we had that really cool spring, there may have been infections early that would have taken a really long time to show up, just as one potential situation that may have played out this season. And so this is why scouting is so important, and making sure to do that for a really long period and at the appropriate time, just to make sure that you're on top of your management. And so these variable springs, early springs, are another thing that is making it more difficult to stay on top of scab management in 2024 and potentially future years. So the next thing that I wanted to do is kind of walk through in detail the NUA infection, or the NUA model, and see when the infection events were, what the season looked like in detail, and then we'll summarize a few specific locations. So I'm using Highland, New York at the Hudson Valley Research Lab. It's one of the earlier sites in the region, and so things are a little bit different here, but it's often a good indicator for the rest of the region. So what happened at the Hudson Valley Research Lab this year is we had this, first I'll back up. So people that haven't looked at this model in a while, just to remind you really quickly, this table is an output from the model. So when you go into NUA and you select your site, you'll also select the model that you want to look at. And then at the beginning of the Scab model, the first thing you'll do is select if your location if you haven't, and the green tip date, and that's really critical. So once you select the green tip date, then the output from the model will include a few different tables, including this one. And so on the first column of the table, you're seeing the date. The next column is indicating whether there was an infection event, which will say yes or no. It turns red when there is an infection event. The next column is the average temperature. And then there's some information about moisture. So leaf wetness, hours of greater than 90% relative humidity, and the rainfall. So we had this really early green tip at the Hudson Valley Research Lab on March 12th that kicked things off. We had a little bit of moisture during this time, but it wasn't sufficient wetting hours at the temperatures we had to produce any infection events. And that cool weather lasted for a long time. Remember, I showed that ascospore maturity curve, and we didn't have any, it was very flat for a long time. And so we didn't have a lot of potential for infection. So no infections were predicted, cool weather and very little rain. So we didn't have an infection or lesion development during this time. And that continued through most of March and the beginning of April until April. We had some moisture in April. So you can see there's some leaf wetness. There's significant rain, almost an inch of rain over here in the last column. But it wasn't significant or sufficient leaf wetness at the temperatures we had to produce an infection event. But if you had covered your canopy, if you had protection out, this rainfall would have contributed to some wash off of that residue. And then around April 10th, we had our first really significant wetting event at warmer temperatures. And so that led to a long combined infection event, 2 infection events, in fact, back to back. And so that combined with additional rainfall, another inch of rain, led to really tough getting back into the field and recovering at a pretty critical time at our first infection events. And then right after that, on the tails of those infection events was another one, more significant rainfall. And so another half an inch or so of rainfall just made like this first infection period very difficult to manage. Then there was another pretty dry period, and so no significant infection events. And then we had another 4th infection event and 5th infection event with really large percent of discharge of ascospores. So a lot of the ascospores were mature by this time, and a lot of really significant infection may have happened. Also, significant rainfall that would contribute to wash off of any residues. And then on May 10th, we had another infection event. So just lots of needing to recover after rainfall, another almost inch of rain, really soggy fields, hard to get back into the field and recover. And then the end of primary scab was predicted. So 100% of ascospore discharge was predicted on May 13th. But if there was any lingering ascospores that were hanging around, or if there was any secondary spores, Canidia, that were available from any primary infection that had slipped through, there was another significant infection event right after this. And so this infection event number 7 happened right after. If you had listened to the model and you stopped covering it on May 13th, this would have been something of concern. And so I tried to summarize all this in a one slide with a graph of the ascospore maturity, the rainfall events, and then I'll show you the 100% ejection of ascospores and the infection events that occurred according to NUA. And that's if you set the green tip date to March 12th. So what you see is were these long extended wetting events long extended rainfall events with infection events where these red bars are. Kerik invented this graphical display of showing this, and I really like it. I think it's very effective. If you set your green tip date a little bit earlier, though, so if you had any host tissue available earlier than March 12th, there was a significant rainfall there, and that would have triggered an infection event. So remember earlier I said that there may have been ascospores present a little bit earlier from the warm winter and the ample precipitation, and so that would have been something needed to be covered for even earlier. There was a lot of rainfall, I just want to point out, that would have contributed to washing off residues and making sure you needed to be recovered. And then after primary infection period was predicted to end, all the ascospores were discharged, there were additional infection events that I pointed out before. And so just tricky to manage all of this this season. Here's, did I skip over? So this is am I going to transition over to Kerik now? Did you want to talk about the other locations in New York?
Yeah, you should probably skip. You had the New Hampshire locations at the bottom. Do you want to go ahead and jump down there and I'll jump back up, or what do you want to do?
Sure, we can do that, and then we'll switch back to you. So sorry the slides aren't quite in order, but I did put in a couple of slides from New England, from Massachusetts and New Hampshire, just to show comparison. It was a little bit different in these different locations. So first looking in Massachusetts at Belchertown at Orchard Watch South, just as an example, green tip was a lot later, so March 29th, and that was just predicted by the model based on degree days. So you may have had a different green tip date for that location. That changes when host tissue is available and when the ascospore maturity begins. And so you should make sure to put in your green tip date. That's really critical. And so you can see primary infection period lasted from March 29th all the way until May 16th. And there were just so many infection events at this location, all of the red bars here. So just as soon as one infection period ended, another one seemed to start. And so even here, like 2 back-to-back infection periods and similar amounts of rainfall. I didn't put that on this graph, but as I looked through rain events that were an inch or more of rain that would have depleted residues. And so also at this location, significant rainfall that would have triggered an infection event if you had green tip a little bit earlier, which, like I said, management earlier can be challenging. And then additional rainfall events that triggered infections after the primary infection period was predicted to be over. So a really extended period potentially. Here's Concord, New Hampshire. So at this site, there were similarly a lot of infection events. So many prolonged rainfall events, again, with really heavy rain, so an inch or more of rainfall that would deplete residues. At this site, there were not rain events leading up to green tip in the same way, so maybe that wasn't an issue. But there were infection events that were happening right at the end of predicted primary infection period and just after. And there was also rainfall in this situation that would have depleted residues, but maybe not have triggered an infection event. Okay, so now I'm going to go back, Kerik, and you can talk about the other New York sites, and then we'll move on.
I'll go ahead and share, so that way I'm just going to replace the current share. No big deal.
Okay.
No one will be alarmed. And then we'll go into it. Okay. I'm going to move some stuff out of the way. Let's hide the video panel and hide floating meeting controls for right now. All right, let's see. Yeah, there we go. We did that one. So one of the things that I do on the Scaffolds podcast and the video channel is each week I give updates. And so what I've done in this case is I've gone back through all my weekly updates and I've found the predicted NUA infection periods and then matched them with the eventual ones that happened, much like in the same format Anna showed. Some of the more, get that reactions thing to go away, will never go away. So this is Chazy, Peru, fairly comparable with sometimes Burlington, Vermont, but Burlington, Vermont can sometimes be very close to Geneva in the recent years. I don't know why that is, but there are some hypotheses as to why that's occurring. But anyway, looking up in the northern part of New York, closer to where Glenn would be, green tip 412. And we had, as Anna mentioned a couple of times, a big wetting infection period right at green tip. And if you had any tissue available, you could be in trouble. One of the things that I've noticed that when Surgeon was in the Hudson Valley, he was often finding ascospores about 10 to 14 days prior to the standard Macintosh 50% green tip date, not 100%, 50% green tip date that is used to sort of start the model. So what I'm often telling people to do on the podcast and on the blog is to take whatever you think the 50% Macintosh date will be and dial it back about 10 days. And if you have green tissue during that pre-50% Macintosh green tip day, and the NUA system will predict when they think it is, so you can go out at around that time and say, oh, I probably should consider things before the 50% green tip model. In this case, something could have slipped through right here. We did predict it with the NUA forecast. The other thing that was predicted was a little blip there, but what was not predicted and what seemed to sneak up in this region in Chazy was this event on 4/29. Completely was not picked up. The one here was picked up as well. Then, I'd make another spray this, spray that, and it matches up pretty well. The other thing that happens most often, I've noticed particularly this season, is you hit 100% ejection, and then much like leaving the green tip 2 weeks earlier, I'm telling people, because these models were built on Macintosh and growth chambers, not outside in the real world, that we need to stay vigilant with our predictions. And so even when it says ejection, I will move the model pieces around so that it's still predicting events to cover some of these nightmarish events that we had for 528, 529, and 66 to 69. And we saw these most of the places in New York as well. And one of the things I also noticed is I was looking around these different locations to pick a location for the talk. And sometimes, like in the case of SOTUS, it varied drastically amongst the various locations along the lake. If you're close to the lakefront, in from the lakefront, more towards Niagara, more towards Albany, things got really different. In this particular instance, we did a pretty good job of predicting. Yes, maybe we over-predicted the number of infection periods, but in this season, it wasn't too bad. I could have moved my orange bars way over here as well on 428 and 429 because I was moving the model illegally to encompass as if the error associated with this maturity curve was real, and it very well is. And so I usually bring things way over here and bring things after when I make recommendations online. We're looking at a spot in Niagara. It was just getting devastated with so much rain, the constant need to recover. If you were planning your big materials, you would want to plan them there and maybe at the very end, because there's a lot of big spikes of rain, and that could really push those secondary epidemics. This one was not called by the model, but was occurred. It wasn't a big event, and you might have been able, in this case, to do it. I think some of the growers did quite well. What else? And so looking at those things, the predictions can miss things as well, but they can also predict over. Some of the stuff that we've run into thus far was that it was a pretty early season and early infections possible. I suspect ascospores are flying through the air when, let's hide this again, before we're seeing green tip and Macintosh. So if you have green tissue out there and model is predicting the model start in a couple of degree days away, you might want to consider. You can fiddle with some of the models and change it and make things predictions show up earlier. NUA, you just change auto enter a green tip date of the current day and be like, oh no, a big infection event. Because if ascospores are actually out there flying in the air, they don't care what Macintosh is. They care about moisture and temperature. And if those conditions are there and you have green tissue, and if previous scientists are finding them at earlier times of the year, then it's possible that you could be in an infection period. And these things are kind of best managed listening to the most regional source of extension content. Whoops, we lost some stuff. A lot of the post 100% ejection infection periods I was really worried about, particularly those encompass 5 or 6 days of leaf wetness, and many are back-to-back. One of the things I like to recommend with a back-to-back infection, particularly if the one coming is a big one, is to save one of your single-site fungicides. Put it right between. If you want to protect forward against the next event, and sometimes they'll give you a little bit of kickback in case things slip through. So if you are trying to recover during those, only got 24 hours, I got to get back in there before the next big rain, saving those single-site fungicides for those times might be best. And then, yeah, obviously, as people have alluded to in the chat, there's no fungicide in the world that could weather the torrential tropical storms because now we're kind of like the tropics. Not that they are literally a tropical storm, but I feel like we're becoming more and more tropical in our area, and it's so difficult recovering. In our UV trials, we were constantly pushing tractors in the mud because in that case, we sprayed during infection events as predicted by the RimPro model. So the soggy fields rain is awful. The one thing that happens is a lot of the big infection periods will come at petal fall first and second cover. I'll talk about this later. A great time to really put in your big guns. But I'm starting to think if you have a wet season with slow drying conditions, it might be best to step away from Captan and Captazeb. And yes, obviously avoid it with oil, but anything with a very oily formulation, such as an insecticide or a thinner, could cause overthinning or cause injury of your crop. So be very, very careful with that. So what factors really make it bad? Weather conditions. If we have a typhoon season or a monsoon season, it's going to be awful between green tip and bloom. Maybe this year we'll have a dry one, and then I'll be talking about fire blight the next year. It's hard to say. These things kind of waffle. We've had some dry years, but this last 2024 was heavily wet after 2023 being a little bit wet. And I think over time, we finally built enough carryover inoculum present on the leaf litter orchard. For the last couple years in Geneva, we were unable to even get a very decent scab trial. But now with 2024, I think we finally built up enough leaf litter. And I'm not managing it, and you should be. The other thing that's really tricky is that it's been hard to get enough protection. You've got to get these things on early to stop the epidemic early on. And this is when you will want to use more of your protectant. Save the fancy stuff for later. I'll talk about that briefly. The last little bit of the talk, I think we'll have plenty of time. I just wanted to talk a little bit about what some of the trends that we've been noticing with the potential loss of multi-site fungicides and how I have been positioning and suggesting management continue on into the next couple of years. In 2025, what I've been recommending is that sweeping urea sanitation prior to the actual bud break, either in the fall or in the spring. I would say attempt to start in the fall, but if you can't get your tractor into the orchard, then try again in the spring. If you can't get it into the spring, then I guess cry, because sanitation can have a huge impact on the amount of inoculum. And then what we've been doing a lot is we've been going copper almost until deep into half-inch green. And for the most part, this has worked fairly well with almost 2 or 3 sprays at Cornell AgriTech without causing damage to Terrence and Susan's varieties. And so we've been really adopting this to get our foot forward. And then after that point, typically this is where I would recommend you do your Captan Mancozeb or Captazeb sort of in your yellow blocks right there. If you have a big infection period early on, one of the really tall blue spikes with a big red bar over it, I might recommend doing an N-linopyrimidine scalar Vanguard. Now, at the same time, Dodine U12 is now allowed up to 2 applications. I've had it in red and pink, but you can go all the way to petal fall. Previously, Dodine was only labeled to go to pink. But now what you could do is you just keep up your Captan Mancozeb, your before bloom, your before petal fall. And if you've already used up your Scala Vanguard early, you want to use this early because it works best in cold weather. And then you come in, if you have another big red bar, use the Dodine. And then once I recommend getting to bloom or petal fall, that's when I recommend bringing in your group 7s, your SDHIs, your group 9, 11s, the QOIs, 3s, DMIs, a 52. That's Axios. It's new material from UPL that's come to market, and I think it should start becoming a part of everyone's rotation. The thing that's nice about these is they're going to get your apple blotch, they're going to get your powdery mildew, they're going to tackle rust a little bit better, and some of the summer diseases. These are already going to start here. That's why I like to position them there. Now, if they strip Mancozeb away from us, you're going to be forced to do the type of stuff in my research. I'll have removed those and replacing them with biopesticides, and I'm moving the single sites forward, which is terrifying, but previously we had 3 groups, now we have 4 that you can rotate. Plus, you can take advantage of that Dodine and bring it out all the way to petal fall, meaning that you could probably still use it if you had rat tail bloom. You might worry, what about resistance to Dodine? We've been monitoring resistance to Dodine since 2006. And all of a sudden, by 2011, 2012, we couldn't find a Dodine resistant isolate. It turns out that we likely selected for DMI resistance and QOI resistance to the exclusion of the Dodine resistant members of the population. And even in our formerly resistant orchard, we've been able to use Dodine very successfully. So what I would say to do is when you're watching the predictions, if it's a light period, and you've lost Mancozeb and Captan's going as well, and you don't want to sulfur cook everything, put the biopesticides in and then bring in the big guns. And I'll show you a little bit about how this would work. Still trying to save many of these for that 3rd to 5th cover. 1st and 2nd, 3rd to 5th cover really hits the apple blotch pretty well. Yeah, you might know it as Marsanina leaf blotch, but Kerry Peter and Surgeon renamed the disease. And even though they don't use the new name, I still honor their research accomplishments by calling it apple blotch. So what am I recommending? So that was a picture, but in a nutshell, word-wise, and if you get a copy of this presentation, you'll be able to just look at this. Fall or spring urea, whenever you can get into the orchard and when the leaves are down. Lei Liang Chang said, yeah, you can spray the leaves right on the tree with urea if you want to do that. This one works pretty well, 40 pounds per 100, or dolomitic lime. There are other types of limes and things out there. Don't use them, just use this one as well. Dave Rosenberger has verified that these are the two things to do. At silver, I really go with the big coppers, the 15% metallic copper equivalent coppers, the co-side, the badge. Save your low MCE coppers for in-season applications where you might be worried about injuring your crop. And then we're doing it again. I think it should be safe going all the way deep into half-inch green or almost tight cluster. Unless you have a really weird variety that gets injured by this. If you have more than 5 days of rain and it's still cold, like you're in Mike's area, use Scalar or Vanguard. That's your AP. That's your 1 group 9. Put that in there. Once it starts to warm up, walk away. These two materials only work against well on apple scab. So let's use up those two frac codes early on. Like I said, I haven't found a dodine resistant orchard. And if you're the first one to have one in 15 years, I'm very sorry, but I'll be very excited to have the isolate. Other diseases just don't work on these. Tight cluster to bloom, saying the same kind of thing. Keep on with these two scab materials. Powdery mildew is just going to start to come in at the end of bloom, but I don't think you have to worry about it right now. And if you're in this period as well, and there's less than 15% ascospore ejection and no rain, this is the chance to use a biopesticide. I find that the liquid formulated products are easier to use with greater success, mainly because they mix better. Some examples, there are many. Stargus, EcoSwing, Double Nickel LC, you put them in the tank, we spray them, and you don't see them at the bottom of the tank after it's over with because they've mixed even with the effort that a small child could use. I also list OSO and polyox, which is polyoxin D, and Howler. I'll talk about why deeper into it. Now, when you hit petal fall the second cover, bring in your big groups and mark how many. You only get to use like 4 of most, and you only get 3 of 52s. And rotate these if you have more than 15% ascospore projection predicted, or 5 days, or 1.5 inches of rain. If it's less, go back to the biopesticides. This is 2026 where the EPA's canceled mancozeb, and we'll assume it's Cap 10 as well. These work great on apple scab, powdery mildew, particularly with the 11 and the 3, and cedar apple rust on the 3. Axios works pretty well on all of them a little bit. It's not the most best, but it is really, really good. The other timings is when some of our studies on apple blotch, aka Marsanina, these are the timings that seem to start reducing the epidemic. It comes in a little bit later than apple scab. Also, you're hitting the initial inoculum for fly speck, sooty blotch, and rods. Once again, if it's less than, use a biopesticide. I'm pushing some of these. I highlighted these in green. I'll tell you why a little bit later. 3rd and 5th, I'm still saying we got to pull it out. You saw what Anna and I were showing with the extended sprays and trouble. 5 days, 1.5 inches of rain. You don't have an ascospore ejection anymore. It's gone. All the models have given up and have moved on. Can you artificially set them back? Yep. And I do, to kind of watch and see what's happening. We find that 1 or 2 applications of the big guns here seems to shut down apple blotch drastically. You don't want to put all of them at the end because that doesn't work either, but that's a different talk. And you can really prevent a lot of that defoliation. Now, if you have in this period here, it's generally we have a drier time. If you had Cap 10 and phos acid, you could use it, but really kind of, if it's less than 5 days, 5 inches of rain, really easy, you need something cover, try one of the biologicals. Okay, why do we say this? They're moving in right before harvest. Try to stay away. If you can have protectants, use them, but I'm assuming they've all been removed. It turns out that OSO polyoxin D is a naturally organic, allowed, true full-on antibiotic that's made naturally. So it has a high level of efficacy because it is kind of like, oh, I put streptomyces in my tank and made it poop out streptomycin that way. Okay, organic, okay. Same with Howler. It turns out that Pseudomonas chloraphis, a strain AS5509, makes pyrrolnitrin, which is a chemical analog of fludioxonil. This is a material we can't have in apples until after harvest. However, you can use this, and that's why in many trials throughout the country, we are finding how to look really well. We're basically spraying naturally derived fludioxonil, a completely different chemistry group, and that's why it's so effective. We're just making a microorganism poop it out, so to speak, so that we can legitimately use it in organic agriculture. And that's why I highlight them in green. Are they necessarily that much better? They've been not necessarily, but they work better in people who tend to not get biopesticides to work. Once again, less than 5, use the other types of things. And as you bring it home, I always recommend finishing fairly strong with a single site fungicide to really knock down those post-harvest. SDHI, QOI, DMI, Sevia is a good one. Maravon, there's tons of different ones. The Maravon and Sevia have a 0-day PHI, stuff like Luna Sensation, Spicer Breast 14. I found that using these at the end really keeps down the post-harvest diseases when you just keep them in cold storage with no ethylene inhibitor. And they, weirdly enough, we did a lot of studies with Luna products, find out they had better color and firmness. Not that that means it doesn't happen with something like Maravon or Sevia. I just didn't do those studies.
I want to thank you both again very much for being here and presenting and the time that you put into preparing. And hope everyone has a good remainder of what's left of winter. It's awful warm out there this week. So thank you all, and we'll look forward to seeing you again at our next meeting if you can make it.